Now we're going to see how to sketch a rational function with a single vertical asymptote. One thing to consider is that both the domain and the vertical asymptotes will come from the denominator, x minus 4. So x minus 4, I'm going to set it equal to 0. So x is equal to 4. The vertical asymptote is at x equals 4, and the domain has to exclude that specific value. So x has to be different than 4, ending up as minus infinity to 4, and from 4 to infinity. The horizontal asymptote, as we previously saw, deals with dual between the numerator and the denominator. So I'm going to sketch the vertical asymptote here at positive 4, x equals 4. And now we're going to be finding the horizontal asymptote. The horizontal asymptote needs to compare the degree of the numerator. Since there is no x, we can assume that the degree is 0, and this one has a degree of 1. So the obvious winner is the denominator. When the winner is the denominator, the horizontal asymptote will be at y equals 0. So I'm going to sketch that horizontal line here at y equals 0. And then I'll be finding the x and y intercepts. The x and y intercepts come from the original function. The y-intercept is pretty much evaluating the function when x is equal to 0. So if x is equal to 0, we have to figure out how much y would be. So we're doing f of 0 is equal to 4 divided by 0 minus 4. You get 4 over minus 4. That's minus 1. The function will cross the y-axis at 0, minus 1 right there. And the x-intercept is the opposite, meaning how much is x when y is 0. So if you think about it, this is y equals 4 over x minus 4. So what we're really asking here is how much is x when y is 0. So 0 is equal to 4 divided by x minus 4. Well, that is a dead end. If you try to solve for x, it won't get you anywhere. So whenever there is no explicit x in the numerator, there is no x-intercept. This graph will never cross the x-axis. So we're gonna move on into finding some additional points. So if you wanna find some additional points, you might wanna use points that at least, let's try to think of 2 points on each side of the asymptote, of the vertical asymptote. 2 points on this side and another 2 points or coordinates on this side of the vertical asymptote. So what are the options here? Well, you could have 3, you could use 2, you could use 1, you could use 6, 7, 8. So let's try to see what happens if I use f of 3. So f of 3 will be 4 divided by 3 minus 4. That is 4 divided by minus 1. And I get minus 4. The coordinate being 3 comma minus 4. So that is 3 comma minus 4 over here. And this graph will be approaching the asymptotes, both the horizontal asymptote and the vertical asymptote, like this. And then I'll be connecting the two values. So roughly, let me try to do a better job there. So something like that. And this will keep approaching the horizontal without never actually touching it. And if I want to find another couple of coordinates further from the vertical asymptote, I could, but we're going to stick with at least two of them on each side. So let's say I do f of 5. That will end up being 5 minus 4 is equal to 4 over 1, the coordinate being 5 comma 4. 5 comma 4 ends up around there. And let's say I want to use 8. Let's say I substitute an 8, f of 8 equals 4 divided by 8 minus 4. That ends up as 4 over 4. And you end up with 8 comma 1. So 8 comma 1 is there. And from this point, I'll be approaching the vertical asymptote. From this point, I'll be approaching the horizontal asymptote, and then I'll have the connection between the dots. In reality, the graph is this. The asymptotes are kind of guidelines, the skeleton that allows you to figure out which values this graph is approaching. But this is what we are going for as the graph of this function.